So once I place this, I'm expecting this one to be energized. I'm expecting this one to be showing that the motor is running. So if I place this, you can see it's a push button. It closed a little bit and then it opened again. But because of the fact that once it closed, this one closed and it's normally closed here. Like that. So basically, that's how you can drive everything. So I know all this might be, if you're new to this thing, it might be so complicated. So let me take you through the simulation and I show you how I build up everything. Yes, welcome once again to this episode where we shall be discussing about PLC programming and other automation instruments we can be using. So today we are going to share about direct online SATAs. As you can see it bare without a PLC, and again I will take you through the PLC and we are going to simulate it to see how it operates. So it's a SATA that is used for three-phase motors. Three-phase motors, they draw a lot of current while at start, so it should be less than 10 horsepower. Machines that are 10 HP and less. Other than that, you're not supposed to be using Delta. This direct online SATAs. We should go to soft SATAs, Delta SATA, Delta Star SATA, and then VFDs, V by F method. That's where you can achieve that. So, taking you through direct online SATAs, we only need a few components. That is an MCCB, or you can use an MCCP, and then an overload relay, which is going to be detecting like overcurrent. When the machine is having overcurrent, it will trip. That's when you see it is drawing a lot of current compared to the rated current. And then the MCCB, it helps, MCB, miniature circuit breaker, it helps through also, that short circuit scenario. And again, it can actually also help in overcurrent, because it has two types of tripping. We have instantaneous, and then we also have like with a lot of time, when you're drawing a lot of current for a long period of time. So it has two methods of tripping. So in this is the control panel of that three-phase motor, and then this is the power circuit. This is our motor, and then this side, the whole of this side is power. So on a power circuit, we have this, and then this other side is a control circuit. So in the control circuit is where we are based. As an automation engineer, as an automation person, your side is a control circuit. You have to develop a logic. How am I going to start this machine? How is it going to work? So in the control circuit, firstly, I would love to indicate to someone that there is RYB. All the three phases are available in the, on the control panel. Let's say I have this RYB. See that? Like, I have to indicate RYB. They are all available. And if by any chance you're using digital displays, it will also be displaying the voltage of the RYB. And then these are the three bulbs, and then I go to the main circuit that is going to start the motor. So when I go to the circuit that is going to start the motor, I have the normal closed contactor or contact of this overload relay. I connect it along in series with the stop button, and this stop button as well is also I choose the normal close in that configuration. So these two are connected in series and they are both in normal close. So on a normal, when I connect power from here to here, it's supposed to be traveling. And when I reach after the stop button, I have to connect the start button, but I connect it with its normal open. So the start button is they are push buttons. All these the two are push buttons. So before you push the start button, you see there is no current that is flowing over here. Power is not flowing over here. So I have to first press. So when I press this, it's actually going to energize this contactor. This contactor, this coil that is energized here, it is the one that is in the main, the main contactor. This was not supposed to be, this is the contactor. main. So we can put the MCB here. You see, the sorry for the mistake. So this is connected to this. So this contactor is here somewhere here, A1, A2. So when it gets energized, it closes. But remember, this is a push button. So once I release, that means it's gonna be not energized. So I have to have something called a holding on. So this contactor is actually having auxiliary contacts. That's normal close and normal open auxiliary contacts. So I got its normal open because when it receives power, the normal open is going to be normal close. So its normal open, I connect it in, I connect a wire to connect it in parallel with the this start button. So when this one gets energized, it gets closed. This one will close. So even if you release here, it becomes open. This one was closed already. So power is gonna flow like this. It's going to keep flowing. And then I will also have an indicator that is gonna be showing like the machine is on, your motor is on, it's running, something like that. So basically, that's how you can drive everything. So I know all this might be, if you're new to this thing, it might be so complicated. So let me take you through the simulation and I show you how I build up everything and match it to work together. Thank you. So welcome guys back again. As I promised you that I'm going to take you through the simulation of direct online starter. So as you can actually realize what in a control panel we are going to be having. So when you're designing a control panel for direct online starters, I'm going to show you to give you a workflow. So you have the three, okay, if it is only single phase and you're also dealing with so guys, as I promised, I'm going to take you through the simulation of direct online starters. And in this simulation, I'm using a software called Simulate. It's an open source software, so you can get it and you just be playing along with the circuit. So after sizing the components, knowing the current rating of the switches, maybe the fuses if you have one, or the contactor, the overload relay, and then as well as the main switch, you come up to now have a workflow of your plan. You already have the casing or maybe the enclosure of the control panel. So you have the three inputs. You have this bus bar coming, the three wires. Um, it's a three-wire four system, three-phase system. So you're going to have RYB entering your panel. So once it gets inside, you connect it to the three bus bars with a variable. If you don't have, you just let it be, but you should be having at least. So you connect it to the three bus bars, and then you pick from the bus bar. You're gonna be picking the four wires to come to this switch, to the main switch. And then after there, you connect the three wires come to this contactor. This is the main contactor, and then this is the overload relay switch, and then this from the terminals outlets of the overload relay switch, you connect to the three-phase motor. So once connected to the three-phase motor, still we connect to this switch, the main isolator. We connect there through wires, one from the R phase, then Y phase, then the blue phase. We connect to the indicators. These indicators are normally on the closing end of the panel. So as if you close and maybe the switch is on, you can see like maybe R, Y, B are available. If one is missing, you will know through these indicators. And then all of them, they are connected to a single neutral. This is the neutral line. You can see it. Uh-huh. So from there, now our main dish comes to the control circuit. So you look for one phase that you're going to be using for to supply your circuit of the control system. So this circuit I have used the red phase, that's the L1, and then it has its circuit breaker, to turn the control circuit on, and then from there I connect the a normal close of the overload relay switch. I connect the normal close with series with the switch of the push button of stop button. The stop button, I connect it in the series with the overload relay normal close switch. So if I have closed here, let's say power will flow directly up to here until it finds this open two circuits. So this is the start button. So once I close here, you can see this is the main coil, the coil of the main contactor. So this, once energized, it will trigger this one to close. But remember, it is a push button. It's a momentary switch. Once I close it, that means this side, and I open it again, power would also be cut off again, and this couldn't be energized. This could be off. So that's how this holding technique comes in. So as when I close here and this one energizes, this one closes, the auxiliary pin of normally open here is going to close, and it is this one. So when it closes and this one you release, power will flow in this direction and your motor will still be running until you wish to stop it and you open from here where everything here is going to be off. So I'm going to take you through the simulation and you see it's power flow. So if I simulate, you can see power is coming and we are supplying to the main isolator, and then also the circuit breaker for the control circuit is also still off. So if I turn on this main isolator, it will power the indicators. It is showing RYB are available in your circuit. But if I have turned on this main isolator here, if I turn it on, you can see this contactor is waiting for the command signal. And this is our main guy, the control circuit. This is the circuit we are trying to build as automation engineers, and we are going to be using a PLC on this other circuit. So as you can see, if I apply the power signal here to close the circuit breaker for the control signal, the control circuit, power flows, as I told you, through the normal close of the overload switch, and then also the push button of stop is connected in the normal closed system, so it will allow power to flow until it reaches here. So this is the push button of start, and then this is the holding contact. So once I place this, I'm expecting this one to be energized. I'm expecting this one to be showing that the motor is running. So if I place this, you can see it's a push button. It closed a little bit and then it opened again. But because of the fact that once it closed, this one closed and it's normally closed here. You see, so power continued flowing through here, and that's keeping this energized. You see, and here it is energized. That means here it has to be closed, and then the motor indicator is showing it is running, and actually our motor is running. So this is how the control panel of a three-phase direct online starter, you have to connect it. And mind you, it should be for machines less than 10 horsepower, because the starting current, once it goes for machines beyond that, it will be actually going to burn the windings of the motor. It cannot last. It really cannot last. So this is how we design the entire system. And in any case, or any inquiry is needed, comment in the comment section. I'll be able to reach to you. Thank you.